Hi, welcome to Zona Mechanica. There is an MCQ on bending moment. Figure at the margin indicates the weightage of the question, that is 1 mark. A simply supported beam loaded as shown below. What is the maximum bending moment in Newton meter? Well, as you can see in this figure, this is the simply supported beam of 1000 mm, that is 1 meter, and it is having a small leg, and there is a load of 100 Newton acting at 100 mm away from the midspan of the beam. Okay, so due to this 100 mm arm, this small arm, this load will create a bending moment, a moment, clockwise movement here, right? So we can assume this configuration as, suppose this is the simply supported beam, and at the midspan a moment, a clockwise moment is acting. Suppose this is M1, and this load will be transferred through this arm over here at the midspan, right? So we can assume this 100 Newton is acting at the midspan of the beam, and due to this arm there will be a moment. Suppose this is M1, so the value of M1 will be clearly 100 Newton into 100 mm, which is equal to 100 into 0.1 Newton meter, right? That is equal to 10 Newton meter. Okay, so now suppose this reaction is R1 and this reaction is R2. Okay, clearly this is 0.5. Okay, so from R1, suppose this is the point A, this is the point B, and this is the point C. Okay, and the entire length is 1 meter. Okay, 0.5 meter. Since it's a simply supported beam, the bending moment at the two ends will be 0. That is, you can say summation of moments at A will be 0. So which implies this clockwise moment will be there. So M1, since it is clockwise, we are taking this clockwise moment as negative, and this 100 Newton will create one more moment that will also be clockwise, 100 into this distance. Okay, so that is 100 into 0.5. This is also a clockwise moment. Okay, and this R2 will create a anti-clockwise moment, as you can realize from the configuration. Okay, so this will be a positive R2 into 1 meter. Okay, so this will be equal to 0. So which implies this M1 is 10. Okay, minus 10 minus this is 50 plus R2 is equal to 0. So which implies R2 is equal to 60 Newton. Okay, so therefore R1 will be 100 minus 60 Newton, that is 40 Newton, right? Now let us see how the bending moment is varying along the length of the beam. Okay, so at the point A the bending moment is 0. Now as we proceed towards the point B, there will be a bending moment which is equal to R1 into the distance. Okay, so at the point B the bending moment will be R1 into this distance, that is 0.5, and plus there is already a moment M1, and this will create a clockwise moment, this will create a clockwise moment, so both the moments are in the same sense, so I am adding both the moments. Okay, M1 just for the magnitude, so R1 is 40 into 0.5 plus M1 is 10, so which is equal to 30 Newton meter. And due to this 100 Newton load at B, the moment is 0. since the distance is 0. But as we proceed beyond B, then due to this 100 Newton force, one more anti-clockwise moment will be generated, right? This force into this distance. So you can realize the sense. So this anti-clockwise moment will reduce this moment, okay, and gradually the moment will reduce to 0 at the point C, okay. So the maximum bending moment is attained at the point B, that is at the midspan, which is equal to 30 Newton meter, okay. So if we draw the bending moment diagram schematically, it will be somewhat like this. Suppose this is the point A, and this is the point B, and this is the point C. Then gradually from 0 to up, this is 20, right? 40 into 0 0.5, this is 20, and this is 10 at the point B acting. So this point is 20 Newton meter, and this is suppose 10. So this point is 30 Newton meter, okay, and then gradually it will reduce to 0 at the point C, okay. So this is the maximum bending moment, 30 Newton meter, okay. So the option B is the correct answer.